All right, so assignment number 2 is about three things again. We have three learning targets. We can solve absolute value equations, absolute value inequalities, and then we can write what are called tolerance situations. That's spelled wrong. Situations three different ways. So let's go ahead and take a look at what we're talking about here. See if you can just take a moment, pause the video, and if you remember how to solve these equations from Algebra 1. First of all, the first one, we did several of these when we were in Algebra 1, where we're just trying to isolate the absolute value part of the equation. So I could start by adding 7 to both sides, and I'd have 3 times the absolute value of x plus 4 is equal to, if I add 7 to both sides, 27. Then I'm going to get rid of the 3 by dividing both sides by 3. If I do that, I'll get the absolute value of x plus 4 is equal to 9. So the absolute value means how far away something is from 0. So we're talking about something that has a distance from 0 that's 9 units. And so if I have a number line up here, it could be 9 units to the right, which would be a positive 9. It could also be 9 units to the left, which would be negative 9. That means whatever's in my absolute value, which in this case happens to be x plus 4, well, that could be equal to 9, or that x plus 4 could be equal to negative 9. And so I'm going to get two different solutions here. If I subtract 4 from both sides on the first equation, I'll get that x is equal to 5. And if I subtract 4 from the second equation here, I'll get that x is equal to negative 13. And just to make sure that both of these are solutions, I'm going to try plugging them both in to make sure that they actually do give me a value of 20. So if I plug 5 in here, I'll have 5 plus 4, which is 9. The absolute value of 9 is 9. 9 times 3 is 27, and 27 minus 7 is 20. So that gives me something that works, a solution that is true. Same thing with this one. If I plug in negative 13 plus 4 is negative 9, but the absolute value of negative 9 is positive 9. And then 9 times 3 is 27. 27 minus 7 does indeed give me 20. And so both of these solutions work. Now, if I move over to the second situation, I'm not sure if you did very many of these in Algebra 1, but let's just go ahead and take a look at this. I want to isolate the absolute value just like I did before, and I'm going to do that by dividing both sides by 2. So then I'll get the absolute value of x plus 3 is equal to 2x plus 12. And just like before, when I wrote two separate equations here, I'm going to write two separate equations for this as well. One equation is that whatever's in my absolute value, which in this case is x plus 3, that's actually going to equal 2x plus 12. The other equation, though, is going to be that x plus 3 equals the negative of this, which is negative 2x minus 12. And I'm going to solve both of those equations. And so here, if I subtract an x from both sides, over on this side I'll have x equals, if I subtract 12 from both sides, 3 minus 12 is negative 9. So it looks like that's one of my solutions. Or if I solve this equation, I'm going to go ahead and add 2x to both sides. So x plus 2x, that's going to give me 3x here. If I subtract 3 from both sides, that's negative 15 over on this side. Here the 3 would cancel. Negative 12 minus 3 is negative 15. And if I divide both sides by 3, I'll get that x is negative 5. So it looks like I have two solutions. Let's plug them both in to the equation and make sure that it works. So if I plug in negative 9 here, I have negative 9 plus 3, which is negative 6. And the absolute value of negative 6 is 6. 6 times 2 is 12. So we have 12 on the left. And if I plug it into the right side of the equation, 4 times negative 9 is negative 36. Negative 36 plus 24 gives me negative 12. Well, that doesn't work. That's called an extraneous solution. It worked going forwards, but it gives me a solution that doesn't work. That's called an extraneous solution. We're going to talk about why that happens here in just a moment. If I plug in the x equals negative 5, well, if I plug it into the left side of the equation, negative 5 plus 3 is negative 2. Absolute value of negative 2 is 2. 2 times 2 is 4. All right, so I had a moment lapse there, phone call, but now we're back at it. So we plugged in negative 5 to the left side of the equation, and we got 4. If I plug it into the right side of the equation, negative 5 times 4 is negative 20, and negative 20 plus 24 is 4. So this equation, this one does work. This is a solution that does work, while this one is called an extraneous solution. So why do we get extraneous solutions? Let's take a look at this situation and see if you can figure this out with me. We have three situations here. And I want you to think about how many solutions each one of these has. So if I have a distance from 0 that's 5 units, this is going to have two solutions because I can go 5 units to the right or 5 units to the left. Here x could be 5 and it's a true statement, and x could be -5 and it's a true statement. So this equation here is going to have 0 solutions because I'm looking for a distance that's -5 units away from 0. Well, a distance of -5 doesn't even make any sense, so I'm not going to have any solutions for part B. If I have a distance from 0 that's 0 units away, well, there's only going to be one solution, and it's going to be 0. So when we have these equations, these absolute value equations, we can either have 2 solutions, 0 solutions, or sometimes 1 solution. And it all depends on what type of number it's equal to. If it's equal to a positive number, we're going to have 2 solutions. If it's equal to a negative number, we're going to have no solutions. And if it's equal to 0, we're going to have 1 solution. So I want you to think about this for a second. Can you explain why the following function could have extraneous solutions? And it depends on what the solution, or what the value of x ends up being. If we have a value of x that makes this equation, this side over here, equal to a positive number both times, I'm going to have 2 solutions. Sometimes this is a positive number. Sometimes it's a negative number. And so if it's a negative number, then we have a situation like this where there's no solutions, and both would be extraneous. And then sometimes we have something like this where we have, it would be equal to 0, and if that's the case, we have 1 solution. So sometimes we have 2, sometimes we have 0, and sometimes we have 1 solution. So, anyway, those are the different possibilities that can come up when you're solving an absolute value equation. So let's move to absolute value inequalities. And I want you to think about these two situations here, A and B. I'm going to graph both of them first, and you can pause the video and try to graph them first on your own and see if you can figure out what's going on here. But the absolute value means how far away from 0 something is. So on a number line here, if this is 0 right here, we're talking about something, about all the values of x's that are 4 units away from 0 or less. The absolute value of x has to be less than or equal to 4 units away. So if this is +4, it would include +4 in everything here. If this is -4, that's also within 4 units away from 0, and everything in here is. So we have something that looks like this, where it could be anywhere between -4 and +4. If we compare that to what's happening here at B, if this is 0, we're talking about all the values that are greater than 4 units away from 0. So we could have a number out here at +4, but that wouldn't work. But anything greater than +4 would work. Also, if I have something here at -4, I'm looking for the values that have a distance from 0 that's 4 or more. So -4 is not going to work, but it would be everything in this direction. And so you can see, based on this sign right here, we get 2 completely different looking graphs. We could write the inequalities several different ways. The way I would write this inequality would be something like this. I would say x is less than or equal to 4 and greater than or equal to -4. So this here happens to be an AND statement. It has to satisfy both conditions. But over here, I could write it like this. I could say, it's n, not x. I could say n, if I look at this part first, n is greater than or equal, these should be closed circles because it's equal to. N is greater than or equal to 4, but here I'd have to say or. I'm looking for the values that are less than or equal to -4. And so here we have an or statement. And so we have different things going on for both situations. Note should be something like this. If I have a less than symbol here, I am going to have an and. Where if I have a greater than or equal to statement, it's going to have to be an or statement. Other things I want you to see here is this. Just like we wrote 2 separate equations when we were doing the equations, there's two separate equations here. If the absolute value of n is greater than or equal to 4, one equation is that n really is greater than or equal to 4. The other one is that n is less than or equal to -4. So this sign switches, and the thing on the right-hand side of the equation becomes negative. They both switch. Same thing could happen here. I could rewrite this over again and say that x is less than or equal to 4. And I could say x is, if I switch this sign, greater than or equal to -4. And if I put an and here, that would be the same thing as what we have here. And so I would just prefer that you write this as a single inequality with three sides as opposed to two separate equations with an and in the middle. And the reason for that is because if I read this one from right to left, x is greater than or equal to -4, and x is less than or equal to +4. All right, so let's take a look at these two situations. I'm going to have you pause the video and see if you can solve these equations here on your own. Hopefully you've done that. I'm going to go ahead and divide by 5 here. I'll get the absolute value of 2x minus 3 is less than 7. So then either 2x minus 3 really is less than 7. And I'm going to switch this around and say that it's greater than -7. And it's an and statement, so I can write it like this as two separate inequalities with an and in the middle, or as one long equation with variables with three different sides. I know it's an and because this symbol here is less than. So to solve this equation, I'm going to add 3 to both sides. So I'll have -4 is less than 2x, which is less than 10. If I divide by 2, I'll have -2 is less than x, which is less than 5. If I solve this equation over here, I'm going to start by dividing by 2. I'll have the absolute value of x plus 5 is greater than or equal to 6, which means x plus 5, boy, I'm really sloppy today. That means x plus 5 is greater than or equal to 6, or x plus 5 is less than or equal to -6. And you see the difference here. Because it's greater than, I'm using an or statement. So I'm going to subtract 5 from both sides here. X is greater than or equal to 1. Or here, if I subtract 5 from both sides, x is less than or equal to -11. And that makes sense here on a number line. If this is 1, I'd have a closed circle here, and it would go in this direction. If this is -11, I'd have a closed circle here, and it would go in this direction. Where over on this equation here, if I went from -2 to 5, it's less than 5, but greater than -2, which would include everything in between. All right, so let's take a look, first of all, at these two statements here. In MathSpace, they require and statements to be written as a single statement. So it'd have to be written like this, as opposed to x is less than 5 and x is greater than -2. If you have an or statement, they don't use the word or, they just use two separate inequalities separated by a comma, and you wouldn't need to include the or. And that's how your homework will look like when you use MathSpace. So let's go ahead and take a look at this tolerance situation. Specifications for a circumference of a regular basketball is 29.5 to 30 inches. I'm going to go ahead and use a second video here because I'm going to be running out of time here shortly. So it should be a second video that you can go to on Canvas to finish this assignment. It shouldn't take you very long.